Okay, class, we are going to learn factoring numbers today. And let's look at some key words or our vocabulary per se. Our first word is going to be composite number. Composite number is a number that can be written as the product of two positive integers. Example, 16 is a composite number because 8 times 2 equals 16, these numbers are factors. 8 and 2 are factors. Also, factors of 16 are 1 and 16 or 4 and 4. Also, we're going to think to our multiplication. 12 equals 6 times 2 or 4 times 3. 6 and 2 are factors, as well as 4 times 3 and 1 times 2. Now, we're going to move on to our second term, composite expression. Now, composite expression is a product of two or more expressions. So, class, we're going to go back to our past lesson and we're going to recall the FOIL method. For example, first is F because it's first. Outer is O because it's on the outside. I is inner because we're doing multiplying on the inside. And then L is last because we will be multiplying the outside. So I'm going to give you guys an example just in case you guys forgot. Our example is x plus 1 times x plus 2. When you multiply x and x, you get x squared. Now when you multiply our first times our outer, it's x times 2, which gives you 2x. Now we're going to do our inner, which is 1 times x, which gives us 1x. And now we're going to add the 1x and the 2x, and we will get 3x. Now we do the last two numbers. So it is 1 times 2, which gives us 2. X squared plus 3x is what we will get when we multiply and factor these out. Now that we know that these are our factors, that's how we got that equation. Furthermore, let's define factors for ourselves. A factor is a number of another number that can be divided by the second without a remainder. Examples, 4 divided by 4 is 1, which gives us no remainder. 12 divided by 5 is 3 with a remainder. Thus, 5 is not a factor of 12, but 4 is. I know that's not written here, but you guys can take that down in your notes. For expressions, a factor can be divided from the expression. For example, if we take a look back at the equation that we just did, x squared plus 3x plus 2, x plus 1, and x plus 2 are factors, but x plus 3 is not a factor for that equation. Why? It cannot be divided by the equation, just like 12 divided by 5 gives us a remainder. Now, let's do some work with our new knowledge. Are you guys ready? Grab your sheet and let's do it together. Every number has at least 4 factors or 2 pairs. First is always 1 and the number itself. Second is always -1 and the number with the opposite sign. So, our example, our number would be 17, and our outer number and 1 would be 1 and 17. And then for our negative, it would be -1 and -17. Our first problem is finding numbers or factors of 18. Let's do this one together. We know that 1 and 8 are factors, but what about 2? We're going to try it out and see what works. So 18 divided by 2 gives us 9. So 2 and 9 would be factors for 18. Now we're going to try 3. And 3 or 18 divided by 3 gives us what? 6. So now we know that 6 and 3 are factors of 18. You can try it yourself, and you can try 4 and 5 just to see if they are factors of 18. And when we do the work, boom, we can see that 18 divided by 4 is 4 with a remainder of 2. And when we do 18 divided by 5, we can see that it is 3 with a remainder of 3. So when we solve out the equations, 4 and 5 are not factors because they cannot be whole numbers. They have remainders. Last slide is the closing where we are going to close out and we're going to discuss further examples, and we're going to work these problems out on the board, and I will be passing out a sheet of examples that we can do together. So I hope you guys enjoyed the lesson, and let's get ready to rock.